Hello, my name is Virginie. I'm from the French National Institute for Agricultural Research. I'm going to present you a chemometrics project massively using galaxy named Chemflow. All that we will see here is part of MOOC's project. This presentation is divided into 3 parts. Firstly, an introduction about chemometrics. Then, in the second part, the Chemflow tool under Galaxy. And finally, I will describe more in detail the MOOC Massive Open Online course. Firstly, an introduction about chemometrics. Now, what is chemometrics? According to the International Chemometrics Society, chemometrics is the science of relating measurements made on a chemical system or process to the state of the system via application of mathematical or statistical method. Okay, well, what does it mean? Chemometrics allows the study of a chemical system for which we consider its state. For example, gluten content of flour and year of production of this flour and some measurements like infrared spectra. Then, chemometrics make the relationship between this state and those measurements using mathematical and statistical methods. To understand well, we have a field of application. From this field, in this example farming, we extract a product that can be flour. Then an operator takes a sample for measuring concentrations, for example, gluten content of this flour, a device called a near-infrared spectrometer. The infrared data are displayed as spectra, and chemometrics is a science that aims to extract information from this spectra. In other words, chemometrics using infrared data allows to predict biochemical concentrations, for example, gluten content of flour, using a model. This type of protocol can be applied in laboratory and efficiently replace experiments, being inexpensive, faster, and preserving the studied samples. In this second part, I will describe the chemometrics tool, Chemflow, that relies on Galaxy. So, why the Chemflow tool? Firstly, we needed to be able to access at distance, for example, with web services, to the different softwares compatible with each spectrometer. Then, we needed to reinforce a community with a collaborative and multi-user system. And because domain contributors develop tools in different languages, R, Scilab, and Matlab, we needed an interoperability tool. Moreover, it was difficult to reproduce data treatment chains, so it was necessary to manage workflows. Finally, today, existing software that are user-friendly are almost all private applications. Or when it's free, it's mandatory to be proficient in programming. For us, it's very important to find an ergonomic and free software. And we wanted to be able to quickly install and propose new methods developed by specialists. It's for these reasons that we chose Galaxy. Let's look at the Chemflow architecture. To begin, users connect using HTTPS protocol. Then, Galaxy has been configured with Apache and Postgre for better performances and security. The Galaxy service is automatically opened after each server reboot. We integrated many specific chemometrics tools that have been implemented in a lot of heterogeneous languages like R and Scilab or Octave that are free clones of Matlab. It represents almost 120 wrappers. A private toolshed is connected to the Galaxy instance and is specific to chemometrics domain. We plan to directly connect Chemflow to the database in order to store and centralize chemometrics data like spectra and metadata associated to spectral devices. And finally, every job is sent to a dedicated computer cluster. In conclusion, this tool allows to share chemometrics data and methods and is freed of any bioinformatics tools. 4 steps to begin to play chemometrics. The first step is to register and be assigned to default group. Actually, there are 3 user groups: default, contributors, and admin. The second step is to log you in Chemflow. The third step is to upload data or share data with other Chemflow users. And finally, you can do science. So, we made a tool configured to be immediately useful. Connect and play. Now, we will see different examples of interface of the tool. At the beginning, we need to be authenticated in order to use Chemflow. In Google Chrome, the tool is automatically translated. Here, it's an example from English to French. We simplified the toolbox, only displaying chemometrics tools and removing useless bioinformatic tools. The tool menu consists in 3 parts. The first one is statistics tools with import data, convert, utils, and basic statistics. The second one is plots tools with histogram, box plot, bar plot, and so on. Here in this example, we have olive oil data with almost 200 lines. Here it's an example of a spectra plot of this data. The third one and the last is chemometrics tools with validation, pretreatment, clustering, discrimination, calibration, transfer, and so on. Here we have an example of a most frequently used model, the PLS, which means partial least square regression. Before I show you a very sexy workflow under Galaxy, I explain you this schematic version. Firstly, we take a spectral data, then we apply on this data a preprocessing in order to obtain an identification model. Then we evaluate this model regarding its parameters. If it's convenient, we are able to predict new data for a given new spectral entry. Here is the implementation of the previous workflow in Galaxy. In the pre-processing step, we detect outliers, then we accentuate the spectra for better prediction. Here are typical graphical outputs of this workflow. We also designed some specific workflows in order to make some functional tests. This example allows us to check the pretreatment tools. I want to emphasize that this tool was built by a small team, which is equivalent to 3 people full-time in less than a year. We also still have three priority prospects. We want to improve our visualization tools with interactive graphics using performant client-side web languages, for example, AirShiny server. We plan to connect Galaxy to a dedicated database containing collections of chemometric spectra, directly accessible from Galaxy tools. This database could be also fed directly from a Galaxy history. And finally, we integrate test and validation functionalities like PlanMO. This tool is part of a project named MOOC. It relies on three pillars. The first one is the MOOC, a massive open online course named MOOC. The second one is a Chemflow tool. And the third one is a collection of data available in databases. Now, I will describe more the MOOC. The MOOC is hosted on a French course platform named FUN, France Université Numérique, France Digital University, which can be compared to Open Classroom. Who created this MOOC? The MOOC has been created by 24 academic and industrial collaborators from all over France and Switzerland, for which we users is this MOOC. So this MOOC targets both students and professionals for respectively initial learning and professional training to learn a new skill or improve on. When is this MOOC? This MOOC will be launched on the French FUN platform on the 12th of September of this year. The registration started the 15th of June in this website. The MOOC will be up from the 12th of September to the 10th of November. We have 26 registrations per day. I checked for you today. We have almost 400 registered trainees. Thank you for your attention. Thanks a lot for this amazing conference. Thanks to G4B School. And if you have any question, feel free to ask. Thanks.
Questions? Anybody? So I think you said this, but how many tools did you wrap for this project?
How many tools wrappers? I have said that.
I think it was over 100.
120 wrappers.
That's a lot.
Yes.
Which one was the hardest?
In 10 months. Yes. Because I begin, my first class is November 2015. Next November. With G4B School.
Very busy. Okay. If no other questions, let's thank the speaker one more time.